Hello and welcome to another Developer Essentials. This time around, we're going to be taking a look at something called player preferences. So player preferences give us a way of storing small, simple little bits of information. And the key thing is they store information that persists even after we close and reopen our project, our game. So it allows us to store information like settings and control options that a player might have chosen. All those little bits of information we can save them. So we're going to see how we can actually use them, see what the kinds of information are we can store and some limitations, and look at a little bit of how we can potentially store some more complex bits of information in there. So that's going to be what we'll take a look at. So if you find these videos helpful, please do chuck in a like or subscribe. They are a huge help if you're able to do that. So let's dive right on in. So for working with this, we really need some information, and we need a setup to see the kinds of things we're able to store. So key thing with player prefs is it really is geared towards storing simple information. So it's not something where we could easily use it for a save game for storing a complex amount of data. That would be quite challenging with it. Technically doable, but very challenging and potentially quite error prone. So player prefs demo. It's just going to set this up, and it's just going to be on an empty game object. So what we'll do initially is we'll do some initial stuff for storing some basic information. So what I'm going to do is I'm going to set up, so I'll have this in the inspector, int, and I'm going to call this demo integer. And I'm going to set up a couple of other ones here where I'm going to have a float, demo float. Let's chuck in a string. So just a few basic sort of types of things that we can actually store. And then another one of demo bool. So in start, I want to load data. So we'll have a specific load function, load data. And we will also have a save data function. And what I'm going to do is, because I'm using the legacy input system in Unity, so what I can do is I can say, okay, well, hit key down, have I pressed key code S? In that case, save data. So key thing when we're working with player prefs is it's a key value storage. And by that I mean that every value that it's storing has to have an associated key, and that key must be unique. So that means that when we're saving stuff, how this ends up looking is we do player prefs save after we've changed or added in all of the things. But before that, we do set. And we actually only have three setters. One for float, one for int, and one for string. So, okay, let's set our integer. So, okay, we can have a key. So how we name these keys are only used internally for our purposes. So we could directly hard-code in the strings there. I would recommend against doing that, just because you're more prone to typos. What I would actually do is something like this, where we have, maybe we'll call it, yeah, we'll go for player pref keys. And then I would have something like a public const string for the demo integer, and that I'm going to name it like this. So when I'm using player prefs, I kind of like to use this sort of almost domain name approach where I'm grouping things. Again, it's only for my benefit, but it's an approach that I find just makes it a little bit cleaner and neater for working with the stuff. So we're going to have our demo float, demo string. And I am going to set up one for the bool, even though, as we saw, there's only set int and set float and set string. So we'll see how we can actually work around that and be able to save out a Boolean. So this is how I've set this up. As I said, this is my preferred approach of having these inside a class like this, because then down here I can say, okay, well, set int player pref keys dot demo int, and then I give it demo integer. And so I can do that for each of my particular ones. So demo float, but I use set float with that. I use the demo string, that will become set string. But then I've got this Boolean. So a Boolean only has two values. It can either be 0 or 1. So our Boolean, we can actually store that using our set integer. And what we do is we could say demo bool, and we use this ternary operator. So what this will do, so the question mark, in this case this is a ternary operator. So what it's saying is if demo bool is true, then this section here, this expression, gets replaced with 1. If demo bool is false, this expression gets replaced with 0. So it's a handy way of kind of doing like an inline if statement effectively. So then I would do player prefs dot save. So here I'm storing the settings, and then to retrieve them back is quite straightforward. So I would say demo integer is equal to player prefs get int. Now with this, I've got two versions of this. I have one where I can give it the key, and I also can give it a default value, or I have a version where I just actually give it the key and it will just return it. I generally use the ones with the default value because that allows me to control what the actual default is for that setting. So demo integer, so I'm going to say that the default is 0. So I would usually recommend using the ones with where you're providing a default. I think that's a better approach, just because it gives you control over what happens for if that parameter is not there. So we've got our float, and again, these are the float, integer, and string are quite straightforward. Now string, the default value, I'm going to say is string.empty. Now a demo bool though, so that when we know we've got a 0 to 1 value, but how do we convert our 0 to 1 value to our true or false? Well, we know 1, we've made true correspond to 1. So what if we do here, is if we say if that's equal to true, equal to 1, then that will evaluate to true, which so 1 corresponds to true, 0 will correspond to false. So let's just test this. We've got our script. We can run it up and it will load up the values. So I'm initially going to put some values in here. 5 for the integer, 1.234 for the float. String is going to be test. So when we run it, I should expect these to change. I should expect it to go to 0, 0, string gets cleared out, which is good. Now, let's set some values in here. We'll give it an integer, give it a float, and we'll set the bool, and then I'm going to hit S to save it. So it should be saved now, which should mean when we load back up, we see those values that we wrote in there, which we can. It's okay. The data's persisting. That's handy. So it's good we know that the data is reliably persisting there. And I could chuck in here, so we can also press a key to perform the loading. Get key down, key code.l, load data. So I won't load it on start, I'll now just only load it when we specifically say. So, okay, that's good. But what if we want to store more complex data? Because we've only got int, float, and string. Now, we already saw one way of working around it with a Boolean. Because what if we've got more complex things? What if we've got an array, for example? So I could have serialize field list, and let's say it's a list of integers. Demo list. What I'm going to do is I'm going to populate this. Num values, random range. I'm going to say a random number of values between 4 and 8. And then demo list is a new list of integers. I can set the capacity, allocate and fill the list. So then what I do is while demo list count is less than num values, demo list add a random range from 0 to 101. So we actually have the full 0 to 100 range. So then for saving that, so I'm going to need to do something like a save int on it, a set int. So what I actually have to do for this is, well, first thing I would do, player prefs set int. Well, I need for the list, string demo list element, demo list, I'm going to have a dot. So this I'm actually going to use as the base for the name. So the keys are going to be generated in code. So what I can say here is if I loop through, so for in index, and I'm intentionally using the integer-based way of indexing this so that I can generate those keys, because each thing needs to be a unique key. So the index is less than demo list.count update index. Then we can do player prefs set int. We need the key. So the element key is going to be player pref keys demo list element plus index to string. It's not cast, convert it to a string. Because then we set int, that element key is set to demo list index. So that will store all of the elements. So write out list. So then loading that in. Well, if we take a look at what I've got in terms of get options, I've only got my 3 gets. I can check if a key exists, but I can't actually retrieve all keys. So what that means is I actually need to have here const string demo list size. Demo list dot size. So this is where it starts to get rapidly quite messy working with it using player prefs, because then I have to do player prefs set int player pref keys demo list size, and then what I put here is demo list dot count, then loading it. Then I have to retrieve from here, so num elements is player prefs. I have to get the integer, then I have to say which particular ones, in this case my demo list size. Default it to 0, and this is a case where that default's really important because if there's nothing there, we don't want to be trying to read data that's not present. So then again, I would allocate my list. So here, read in the size of the list and allocate it. Then I read in every element. Read in every element. So for index is 0, index is less than elements. And again, I can retrieve the stuff here for constructing that key because that's going to be the same. But then what I would do is I would say, well, demo list, add, player prefs, get int, element key, and default it to 0. So if you can imagine, every single list we would have to do this for, which does get messy. We're going to take a look and make sure that this works. So we'll have our list here. It will initially be empty, and then when we run, this will get populated. So we've got 4 elements there, which is good. So I'm going to save. So we've saved all the data, and then I'm just going to actually clear everything. And then let's load the data. Loaded the data, we've repopulated the list. So, okay, it works, but as we can see, it's quite a lot of extra lines for this. And, we'd also need to save positions. And so, okay, well, let's chuck in a vector3 for a location. And look at how we have to save that out. And also, well, we also might want to save a rotation, which that rotation, we might be saving that as a quaternion, for example. So demo rotation and demo location. So let's add in each of these because we want to have proper, see what it's involved in saving all of these different ones. So we know we're going to have keys for these. So demo location, so demo dot location. Going to have a similar thing for our quaternion. And we already know that, so in the case of our location, that we have x, y, and z values. Now those are floats. So actually our demo location, and we'll end up with the same for the rotation, they have a dot at the end of it. Because what we have to do is, for saving out the demo rotation, well, we have 2 ways of doing this. Because our demo location, we can convert it to a string. So that is a thing that exists, but then we would need to parse that string. So while that's simple on the saving side, on the loading side, we're then having to parse that string. And it's not necessarily the best way of actually storing it. So we are actually better off going for a player prefs set float, demo location, and this is where what we can do is best option is probably going to be to have x, y, and z components do this. So x, y, z. String would obviously be able to be as a single thing, but then our loading logic is more complicated. So it's a balance between that complexity on each side. And that's not an unusual thing, that the loading and saving logic, the complexity differences between them can be quite substantial. So our demo, we have our player pref keys demo location x is demo location dot x. And then we end up doing the exact same thing. Actually, this is our set, so we'll move this down here. So then we have the same thing for y and z. Now we could certainly set up some wrapping helper functions around this stuff. So we could set up a thing for a set array, array of integers, set list of integers. We could set up helpers for stuff like of this. And if we were doing a large amount of this, that would absolutely be the right call to do that. In this case, we're not needing to go too complicated with this. But I'm going to retrieve this. And one of the advantages with the functions is they are very similar. So the setting and getting is actually quite quick and straightforward for them. So our demo location X, demo location Y, and demo location Z. And we default these to 0. So this will restore the location, or load the location. And then this will save the location. What about the quaternion though? I haven't really looked at the internals for a quaternion, so let's take a look and see what we've got access to. So demo rotation. Just want to see what particular things we have that we can specifically access. So we do have these W, X, Y, and Z, which the values there, we can't directly modify them. So those are not intended for us to directly change. And as we can see, even the thing is warning us not to do that. Well, it does at least say unless you know quaternions inside out, which while I don't know quaternions, I like how the instruction is different. For W, it's a case of don't. For X, Y, and Z, it's a case of only do this if you know what you're doing. I'm curious if there is actually anything much different in terms of... No? Okay. So we are going to be able to save out the individual components. This is something where, although it's saying, yes, only do this if you know exactly what you're doing, what is the case here is because we are actually going to be just saving and loading these, so we're not modifying these, we are using just the base values for it. And we're just going to be restoring them, so it's going to be fairly safe. And this is something where I am going to reuse the code from here, because it is going to be almost identical for this. So whereas these were location, I'm going to use rotation. And then that just makes it a little bit quicker for getting it set up. And we grab W. So save the rotation. And then it'll be a similar thing to up here for restoring it. So load the rotation. We will have the one for W as well. So demo rotation. And again, this would be one where if we were doing this on a larger scale, we would want to set up helper functions for this, just because otherwise it's a lot of manual code that we're writing, and there's a huge potential for errors there with this. So we're going to test this out. We want to make sure the locations are able to save and load. And you can see the rotation there. So we'll run this. And then I will load the existing data. You can see our vector here doesn't change. I'm going to set some initial values for this stuff. And we'll go from there. So we save. So information is saved, and then we load. Nothing changes, but let's reset everything here. So we'll reset the component. Manually put all of these back. Clear all of this, and then load the data. and we're able to be successfully loading the information. So we can work with player prefs for simple data, and it will save and persist as we've seen across different runs of our project. But we do run into issues when we are working with sort of more complex data. So this is something where a good approach that we could do with this is we could set up a new file that is player prefs extensions. And what we can do here is bring in our general collections, have a public static class, player prefs extensions, and then we could set up in here things like a public static void set vector3 that gets given a key and then a vector3 value. Now, if you've seen extension methods in C#, we can't actually do that with player prefs. So extension methods in C# work only on an instance. We can't add an extension to a static class, unfortunately. But this will let us can access player prefs, can do a set float of key plus x to value.x. And then we can also do that with y and z, y, z. So that then over here, what we end up doing is, well, demo location, we get rid of these ones because we don't need them anymore. And we just have our demo location. And then our set down here becomes player prefs extensions dot set vector3 player pref keys demo location, and then we give it that location. I'm going to comment these out, and we might as well set up our get version of this as well. So the get version is going to return a vector3, takes in a default value, and then here we're doing a get. We set up these, and what we would do is there's different ways we could go about approaching this, but I would say probably something like this of vector3 value, value.x, value.y, value.z, and then we return it. This simplifies our code quite a bit. And we can see we end up with demo location is equal to player prefs extensions dot get vector3. We give it player pref keys demo location, and default in this case becomes vector3 0. So let's check back in Unity. So we've done a bit of code, we always want to make sure we're returning back to Unity. So we can see it's getting a little bit grumpy because this needs to be get vector3. So let's test. And then that needs to change to set vector3. So part of the advantage with regularly going back to Unity is it means that the code's compiled. We spot those errors early on. And we'll test to make sure that this is still working for retrieving that location. So let's check, set these values to something and save them. So saved, we'll zero them out and load them, and they restore back. So this is what we could do for if we were doing a lot of stuff with player prefs. we could migrate the things into just a little static class that then means we have these simpler interfaces. It's still a lot of extra overhead. We're still manually going and saving each individual variable. If we're looking at saving more complex data, then what we want to look at is more stuff related to serialization, which I have put together another video that's specifically a deep dive looking at serialization approaches when we're working with complex data. The other final thing is with player prefs, what if we want to get rid of all the data? So with player prefs, we can say f input, I'm going to do get key down, key code dot delete. So if I've pressed delete, I want to just get rid of all the player prefs. That's easy. I can do player prefs. So I have the option of deleting an individual key. So if I was wanting to reset a specific setting, I could do that. Or I can delete everything, and that will clear all of the keys. Because what I will find is what I'm going to do is I'm going to run, and then I'm going to load the data first. So I've loaded the data. Now I'm going to hit delete to clear out all of the keys. And now I'm going to hit load again. We can see everything goes back to the defaults. So easy way if we wanted to have an option for the user to be able to reset all of the settings to their defaults, we can do that by they just can delete all of the keys and then we can reload in the data. So just recapping with player prefs. They give us a way of saving and loading simple information. It works across different platforms. It will persist across a game starting and stopping. So we can store simple information, but we're constrained to 3 types: integers, floats, and strings. So anything outside of those types, we need to convert it to one of those. Booleans are a straightforward one. In terms of Boolean, we can turn that into an integer of a 1 or a 0. Stuff like vector 3s and quaternions, we need to save out typically each individual component. Similarly with a list, we have to save out the size of that list and the individual elements. Again, we could pack that list into a string, but then we have much more complicated code for the deconstruction of that. And so as we can see with this, player prefs is great for simple data. As soon as we start to get to really complex data, if we're storing a lot of stuff like stats, where it's different, my character might have different items that might be different classes and different types and different stats within those, that starts to get really, really messy. And it starts to get well beyond what we could reasonably do with player prefs and what we should safely do with player prefs before it starts to get really messy. And that's the thing, when we have those more complex sets of data, we want to look at serialization-based approaches. Those will work out significantly better for us and will give us a much more robust solution. And I will put a link below to video on that serialization approach. But check out the stuff with player prefs. Have a go at setting up other extension methods here. We've seen the template for working with vector 3s. So set up ones for quaternions, set up ones for lists or arrays of integers and floats and strings, things like that. Set up a few more of those ones and see how that goes, see what it looks like for working with that, and see if you can find other ways that can potentially simplify it, and see what kinds of data you're looking at saving and how well they can be fitted in with this. But dive in and experiment with it, see the kinds of things that you can create there with it. Thanks, folks. If you're looking for the code for the project, then in the description below, you'll find a link to the GitHub. And on the GitHub, I've got the code for this project and for all of the other projects. They're freely available. And if you have found the video helpful and you'd like to support the channel, then throwing in a like or subscribing is always a huge help. If you're looking for further ways to support, then I do have a Patreon set up, and that's going to help me keep managing to do these videos for a long time to come, which is going to help more people make cool things. And that's awesome, because that's what this is all about, is helping more people make more cool things. And that is all. Thank you.